the fundamental theorem of algebra that states that every non-constant polynomial has at least one zero. So for the proof, let's take one non-constant polynomial. So let Pz be that non-constant polynomial and let this be equal to a0 plus a1z plus a2z square, so on up to a n z the power n, where this a n is non-zero. Now we need to prove that this polynomial has at least one zero, right? So let's do this proof by the contradiction, and we suppose that if possible, this Pz never vanishes. So suppose Pz never vanishes. If Pz never vanishes, that means it's reciprocal, that is 1 over Pz. This is an entire function. What is an entire function? The function which is analytic on the whole complex plane, right? And when the function is analytic, if its derivative exists at all the points on the plane, that is the entire complex plane. Because this Pz never vanishes, so 1 over Pz is always defined. Yes, so its derivative exists. So this is your entire function. Because this is an entire function, I can take my z as large as possible. So let's say 1 over Pz will tends to 0 as z tends to infinity. So now let's apply the definition for this. Thus for epsilon equal to 1, there exists a positive real number r such that the mod of 1 over Pz, this is strictly less than 1, because as it is tending to 0, I can take this as 0 point something. So let's take this mod to be strictly less than 1 for mod z greater than equal to r, right? So therefore, which means this is now bounded for mod z greater than equal to r. So therefore, 1 over Pz is bounded for mod z greater than equal to r. Please mark this as 1. Now since 1 over Pz is entire function, right? Because it is an entire function, so it is also continuous. So 1 over Pz is continuous. So therefore, 1 over Pz, because it is continuous, so 1 over Pz is bounded. Now for mod z less than equal to r, right? Please mark this as 2. There is a remark written over here. A bounded closed set is compact. Now mod z less than equal to r means z is less than equal to minus r and plus r. So this is bounded, right? And also it is closed because of the signs less than equal to. So 1 over Pz is bounded on compact set mod z less than equal to r, right? Please mark this as 2 now. So from 1 and 2, what we conclude? 1 says that 1 over Pz is bounded for mod z greater than equal to r. 2 says that 1 over Pz is bounded on compact set mod z less than equal to r, which means 1 over Pz is bounded for whole complex plane, right? So from 1 and 2, we see that 1 over Pz is bounded in the whole plane. Now what we got that this 1 over Pz, first of all, it is an entire function. And second, it is also now bounded. So if 1 over Pz is entire function and also bounded, so what Leibniz theorem states that a bounded entire function is constant, right? So this we have to write in the next step. Now since 1 over Pz is bounded entire function, therefore by Leibniz theorem 1 over Pz is constant. And what we have supposed that 1 over Pz never vanishes, right? So this supposition is now wrong, because they are saying that 1 over Pz is constant, right? It can attain the value as 0. It may vanish at least for 1 0. And hence, Pz is constant. If 1 over Pz is constant, we get that Pz is also constant. So therefore, our supposition was wrong. Thus, Pz vanishes for at least one value of z. Hence, pz has at least one zero, right? Okay, thank you.